Hello everyone, I'm Lena Amrani, one of the judges for 2024 ASTI Feynman Challenge. Today, I'm excited to share with you an incredible learning method known as the Feynman technique, which can greatly enhance our understanding of complex science concepts. Then later, we are going to put this technique into practice by applying it to physics. So let's start. First, before I dive into the technique, I need to talk about the brilliant mind behind it, Richard Phillips Feynman, who was a Nobel Prize winning theoretical physicist known for his work in quantum mechanics. So we need to ask ourselves, what is quantum mechanics? Quantum mechanics is the science that deals with the tiny particle that everything in this universe is made of. It sounds complex, right? But actually, what made Feynman unique is that he has an ability to explain these complex scientific ideas in simple and accessible ways. So, the technique of explaining the concept scientific ideas in simple, accessible ways is called the Feynman technique, which is a learning method that makes understanding science not just easier but also more enjoyable. By teaching complex concepts to others in simplest terms, it enhances what? Understanding, retention, and practical applications. Ultimately, what? It boosts problem solving skills. So after I explained the Feynman technique and what does it mean, now we need to talk about the steps of the Feynman technique. So this technique is straightforward. So it involves four key steps. So choose a concept, explain it to someone in simple terms, like if you are teaching it to a child, then you're gonna identify the gaps in your explanation, what was missed or not well understood, and study it again. And then the fourth one, you're gonna review and simplify further. This method helps solidify your understanding and allows you to communicate complex ideas clearly. After we covered the steps of the Feynman technique, we want to apply this to physics. So, can we apply this technique to physics? So, by taking big, daunting concepts and breaking them down into simpler, digestible parts. Today, we'll do that by learning how to build barometer, which will help us understand atmospheric pressure and weather prediction. Okay. Do you remember when we said like there are four steps in the Feynman technique? So the first one was what? Choosing a concept, right? So our concept today is the barometer, which is a tool that measures air pressure and helps predict weather changes. With high pressure typically signaling what? Signaling sunny skies and low pressure indicating potential rain. A barometer is a fantastic tool for any budding meteorologist. Meteorologist is the type of scientist who studies the atmosphere to predict and understand the Earth weather. That they are the ones that help us prepare for each day's temperature and let us know whether to expect rain, snow, or sun. Now we need to understand our scientific concept. What is atmospheric pressure? So we need to delve deeper into atmospheric pressure. Imagine the air around us like a huge ocean of air. Just like water, air has weight and presses down on everything it touches, well, which we call atmospheric pressure. Think of it as a balloon you blow up like this. The air inside is pushing what? Is pushing against the balloon's side. That push you feel is similar to atmospheric pressure. So the air inside that pushes against the balloon's sides is what we call high pressure. High pressure, which means that there is more air pressing down on a certain area. But when we release that air, so there is less air pressing down on a certain area. And here we are talking about the balloon sides. So after we talked about the low pressure and high pressure, we need to see to understand the effects of these pressures. So when there is low pressure, the air rises and cools. The moisture in the air condenses to form clouds. These clouds can become what? Become heavy and lead to rain, storm, or even snow, depending on what, of course, depending on the temperature. On the opposite, when there is high pressure, the air sinks and warming up as it descends. So this warming helps to evaporate clouds, keeping the skies clearer. So high pressure often brings sunny days, making it great weather for what? Of course, for outdoor activities. So now after we understood our scientific concept, we need to build our own barometer at home. So let's build it. What we need is just few simple items: a clear jar, a piece of balloon, and a rubber band, a straw, some papers with pencils, color pencils or markers, tape, and a scissor. So with these tools, we are going to create a device that shows us how changes in air pressure can predict the weather. So let's start construction our barometer. First, what we're gonna do, we're gonna take the clear jar and cut a piece of the balloon. This piece, we're gonna cover the opening. With this piece, we're gonna cover the opening of the jar, ensuring is tight, flat, or smooth. And then we take the rubber band and we secure the balloon with it. So as you can see, now we need to take the straw and put it on the top. We need, of course, piece of the tape. We're gonna place the straw on the balloon surface and secure it with a tape, as you can see. Let's take another piece to secure it better. Okay, done. So after placing the straw, which will act as an indicator, we need to create our weather background. So we're gonna take a piece of paper and then fold it like this. And then we're gonna choose our starter point, so which is here, and we're gonna draw on it. So we're gonna create lines which will indicate on the top and the bottom of the paper. And then we're gonna draw a sun on the top, and rain, of course, on the bottom. And then we're gonna place our paper in here. We're gonna put our paper in here. So after making the homemade barometer, we're gonna observe where the straw is going to go. So now we need to watch the direction of the straw points on our home barometer. So if it moves towards the sun, which means the air pressure is likely high. So actually the homemade barometer traps the air inside of it. So as the atmospheric pressure like outside goes up, the air presses down on the plastic. So when it pushes down on the plastic wrap, then the air inside is pushing up. This makes the pointer goes up, suggesting good weather ahead. But if it points towards the rain symbol, it indicates that the atmospheric pressure is outside is low and it drops. So the air inside the jar is pushing up more than the air outside, like this. So this one indicates low pressure and could mean rain is coming. So now you need to record the position of the straw daily to track changes and start predicting the weather, like a scientist. Now we come to the end of our video. So I just want you to know, so by building and you're using your own barometer, you're not just following instructions actually, you are engaging in scientific inquiry. Challenge yourself with questions like why does high pressure mean good weather? And why does low pressure mean bad weather? Using the Feynman technique and explore and explain this phenomena. Each observation you make contributes to your understanding of how weather works and showcases your Feynman skills. Just a tip: when you are making your videos, when you create your video, concentrate slowly on explaining the chosen concept, scientific concepts. You don't have to do like me and explain the Feynman technique from the beginning. So it's not necessary for you to discuss the process you use to develop your project or mention Richard Feynman or the Feynman technique. So your primary goal is what? Of course, is to ensure that the key scientific principles are clear and comprehensible to your audience. So now go and grab your camera and show the world what you know. Let's see your Feynman skills in action. We are waiting for your videos.